Hello, everyone. So, this is our weekly webinar for the project overview in the data science and degree program. Actually, the last webinar we had was on Keras stacked autoencoder. I hope you found it useful. Before that, we also talked about some exercises in the PyTorch, and also earlier than that, we also talked about PyTorch. So there was PyTorch overview, and then there was some exercises on it, and then we did some work on Keras. As you all know, last week, as I have been traveling quite a lot, I could not find time to publish this that earlier week's webinar. So this week we will be having two webinar. So this after this one we'll be having one on maybe this Saturday or Sunday. Okay, so this one will be quite short. There is not much to discuss. This is about overview of the project, and since you know the deadline is in next 2 weeks, so maybe this will help you to complete the project on time. I already shared all the different components with you that you can use to submit this project. So maybe then we can uh, now we can just see the project and see how those components that we did earlier in previous webinars can be used here. And so let's go. Let me share my screen first. Okay, this is my entire screen, and okay, yeah, I hope it's visible to everyone. Now let's see. Um, okay, so as you all know, last webinar we did three exercises: saving and loading models in PyTorch, and loading image data in PyTorch, and then transfer learning. So basically, saving and loading models was the aim of this exercise was to show you how you apply some how you load the models, how you save the data, save the models, apply some transformations on them, train your network, and then use the checkpoint thing. The checkpoint helps you to save the current status of of the model. Then you can load that status later on and also can train it further. So basically, you can run your training on in batches. Okay, and then after that, we talked about loading image data. In image data, we worked on the data set of cats and dogs. We loaded some data from these folders and then transformed them. And then we just showed how the images look. We also applied some data augmentation part. So this all this code you can find it on previous webinars. Maybe the one before the Keras direct autoencoder. And there here we trained our network. We created a network from our own, and then we just ran the training on it. Okay, and after that we run the transfer learning. So transfer learning is quite important thing, and it's quite useful in industries nowadays. So here you have already trained model, and then you try to load that model and tune it for your own problem. So the model quickly adapts to the new problem, and then it contains the learning from the previous data set as well as new data set that you have trained it on. Right, we use the densenet network, and then we checked its performance. We trained the network further, and then we tested it, right? So now, if it's okay, but then I'll have to see. Okay, yeah. So now we'll be talking about this project. So after these two modules, we have this project image classifier. Its deadline is due in 2 weeks. So maybe you will. This project is not that hard. It may be longer, lengthier than the first one because it contains. It takes a lot of time to train the models, and for that you have the GPU space with you. So here you can disable or enable the GPU space. I have here enabled it, and GPU works quite fast as compared to CPU. It parallelizes the whole process and then can run your training quite fast, which is why you have this workspace of Audacity GPU. Okay. Yeah. So now let's see what is the project about, and then we can move on to. So in this webinar, I'll be talking about the part one of the image classifier project, and in the next webinar, I'll be talking about the part two. So you will have to submit both of them together. So earlier there used to be a submit button here in the bottom, but this time it's not. So you will have to submit both of the projects together, right? Okay. Yeah. So the problem is that in this project you will train an image classifier to recognize different species of flowers. Here are the examples: hard-leaved pocket orchid, Cortellia spicata, orange dahlia. You can imagine using some things like in a phone app that can tell you the name of the flower your camera is looking at. Or you also know about Google Lens and all. So you click a picture using your Google app, and then it quickly finds out what it is that you are looking at. So similarly, this kind of application is possible with this project. So here we are simply building a project where we will see the image of a photograph of a flower, and then we will tell which kind of the species the flower is of. So the project is broken down into multiple steps. You first load and pre-process the image data set, train the image classifier on your data set, and use the train classifier to predict image content, right? So here for loading data, right, these libraries, they are already there. For loading data, you need, you can use this thing that we did in the exercise 7, loading image data. You see how did we loaded the image? There was a data directory that we defined. You can see the same thing here. There is data directory defined, and there are directories defined for train directory, validation, and test. And then you will have to apply some transformations. You may need to use some transformation to image, because you cannot use you do not always get the data in your preferred format. Even the data may contain images of different sizes. You want to make them uniform. You define a transform which resizes the image to 255, crops out the center part, and then it converts it to tensor, because in PyTorch we always deal with the tensors. Now you create the image folder, and then you apply the data loader, right? So this part we already had done earlier. You can just use this part to complete here, right? It's already there, I guess. This thing, this much is already there, or maybe I did it, I don't know. So maybe it was already there. So that helped. And then label mapping. So label mapping is already there. You do not need to do much in it. Okay. Now building and training the classifier. So in building and training the classifier, you see there are things you need to do. You need to load a pre-trained network. And where did we do it? We did it on transfer learning. We imported a dense net, right? Let's see. Okay. So in transfer learning part, yeah, here we loaded the dense net, and in the project we need to we need to load a different network. We can do VGG, or we can do let's say VGG 16, and there is VGG 19, and RESTnet 50 is also there. It works quite good. So you see, you do not need to bother much about it. You already have done this part. Just need to load it like this, and then you will be good to go, right? So all of these components we already have done. In this project, we are just assimilating all those components from different exercises, right? Okay, now maybe I have some message. Yeah, no, that's not for you, right? Okay, yeah. And now, so then you load the pre-trained network, which can be VGG, RESTnet, or anything you are getting good results in. So, and now then we defined untrained feed forward network as a classifier using ReLU activation and dropout. So where did we do it? We already did it in this part, right? Here we defined our own network, own classifier. But what is it directly asking? It is asking for a feed forward network as a classifier. It just wants the classifier part. So that we also have done. If you see here, uh, so we have defined the classifier here. You just need to repeat this part here as well, right, in the project itself. And then It is asking you to train the classifier using back propagation. Then you again go to the transfer learning part and you see, are you doing it? Yeah, you are doing it, right? You are doing the backward propagation, you are doing the model, you are doing the classifier, you are using the model as DenseNet here, and then you are applying classifier to your own defined one, and then you are applying the backward propagation. So basically, this whole project could be done only with the webinar that we did before the Kiras one. All the components were already there. I am now in this webinar. I am only guiding you how to take out these components from different exercises, and then you can apply this on your project itself. Right now, it asks to track the loss and accuracy on the validation set to determine the best hyperparameters that we also may have done. Okay. So, let me see what is the trick, the loss and accuracy on the validation set. Yeah, okay. So after training, we also test it. So you can test it on validation data set and you can see the accuracy and loss of the data here, right? We also did it on the CAD part, the loading. You see here we also have defined our own network. And in the project, you only need to define the classifier with the pre-trained model. Then you apply the training and then you test it on the test set, right? Okay, let's see. Okay, now it is asking you to build and train your network. It's quite easy now. You just need to load it and then you need to add it to your classifier. Then you get your whole model, right? You define your model as DenseNet or VGG or anything, and then you define your classifier, and then you attach this classifier to your own model that you loaded. Okay. Now, after the training is done, you need to test your network, right? So this is even this part is not hard because we did it in here. So after training it, yeah, we just you can just take out this part of code and attach it there. It is basically doing all those things that you need for testing. And it is, you see there, this thing you can change. There is this criteria. I am using NLL loss. And also for accuracy, maybe we can write something in it. Let's see. Okay, so maybe I won't do any changes in this part in this project file. You can do this later on your own, right? Maybe then I can just define my own. Okay, let's see this. Okay, maybe something is wrong. My system is hanging. Yeah. Okay. Now let me define some function, right? Let me define def check accuracy. It's how you can do it, right? I pass the argument as test loader, pass the model, and I pass the device. Okay, maybe I can pass the device as torch.device, right? And CUDA if available. This thing we also did earlier, right? Here we did this, right? So we just take out this part, pass the argument in the device, and then now that we have device, now we have all the arguments. Now we can start testing it out. Okay, so I won't be running anything here because with this code is quite old. Um, but I can make this code for checking the accuracy. Let's say, let me make it the count part, count correct, equal to 0, right? Now let me total equal to 0, model dot to device. Okay, so I am just doing this simple stuff that I already did here. Maybe then I can just copy here. Okay, so yeah, even then you copy this part and then make it here, right? Okay, maybe here. You see, this is a standard code. Now it is ready to be used in the project when you will be checking your accuracy, right? So basically, we already had did this. We here we are just naming it with check accuracy that you can use here in this project. Okay. Now after that, what we need to do, we need to test the network. It is done. Now to save the checkpoint, we already have done this saving and loading model part, right? So you see, you save the model by this command torch.save, and you save the state of the model in the state dictionary, right? And whenever you need to load it, you can always load it using the state dictionary, which will contain the status of the network. Now here I can add the components I need in the checkpoint. It can be input size, output size, hidden layers, and state dictionary. I can maybe have less than these or maybe more than these. It depends on me, right? This part you will also find on that webinar, because fifth, sixth, seventh, and eighth exercise we did that day. Now we can save the checkpoint like this, and we can load it here. Like, we just need the file path, we load the checkpoint and extract out all those vectors and add it in the model, right? So you get this, you can also copy paste this part here and it will be done, right? This is loading the checkpoint only, so this will be sufficient for this part. Now so now for processing the image, maybe I did not do it earlier. So for processing the image, they have given me the instructions, right? Okay, so maybe I can do it like right now. So they use PIL. Have I imported it, PIL? No, I have not imported it. Maybe then I can add PIL. Huh? Yeah. So maybe I would do this part for you here, because other than this, all the parts are already done. Like, maybe let's say, so we do the PIL imaging to open the image, right? Open image, and we extract out the thumbnail. You see, they have there is a link for this. You can check it out, right? So I already have done this thing earlier, so I remember it. So I need to here pass it with the number of pixels that I'm getting here. So 224 and 224 is the size that I need to extract. So that will be my 225 will be the value, because it's indexing from 0 to 2 to so there are 225 values, and 0 to 224 is my index, right? And then after this, I do PIL dot, okay, maybe dot anti alias, right? So anti alias, you can Google anti alias PIL, right? So what does anti alias does is, anti alias gives it a different name, right? Okay. Maybe then I can show you some documentation. Dot anti-alias. Okay, there must be some definition of anti-alias. It is used quite often in PIL. So basically, we do this with different name of the image, right? They have not defined it. Okay, that we can find out later. Maybe there must be some documentation here about that. So let's leave it for right now. Okay, we'll go on this to later, this filter of image anti-alias, right? So this is a standard practice of using it. I can now do this thing. So now we have extracted out of the thumbnail the small part of the image, and now let me define the size of image. Size equal to maybe 224, right? Left would be width minus height. Oh, sorry, width minus image size, because now we are talking about the half part of the image, right? Right would be the whole width minus the image size that we are going to extract from the original image. Size by 2. Okay, this should not be right. This should be top. Okay, right equal to plus g size by 2. Left equal to height plus img size by 2. The right is already done, then bottom comes after right. Okay, now we are ready to crop it. So, okay, left, top, right, bottom. So this part that we define here, this whole part will be extracted out from the image itself. So np image will be np.array. So now we are going to normalize it because the maximum value it can achieve is 225. Okay, sorry, 255. Also the mean they have defined already. So we will use this part as it is. The means equal to np.array. Okay. std equal to, so this was as same as this, right? So you see, I'm not using any additional information. Whatever the instructions have been given to me, I'm just making use of them, and they are quite sufficient to complete this project. So now I'll do the same transformation that I did earlier. You may see earlier when I defined the okay, standard tensor. Okay, so this is already using the normalized part. Maybe somewhere we did it in some of the exercise. Okay. Yeah, so don't much note is needed. We know the formula. Formula is x minus mu upon sigma. That is the data minus mean upon standard deviation. We'll just use it as it is. Is standard deviation. Then we return np.transpose. Okay, now why are we using this transform? This transpose is used because it has been instructed to us in this part, right? So finally, PyTorch expects the color channel to be first dimension, but it's the third dimension in PIL image and NumPy array. You can reorder dimension using transpose. The color channel needs to be first and retain the order of the other two dimension, right? So color channel is the first one, 2, and needs to return the order of the other two dimensions. So 0, 1 are as it is, right? Okay. So yeah, after this there is I am show. I am show is already there. Maybe I pasted it or it was earlier there. So I am show. Now you can see the image. So you see, after pre-processing the image, now you can see we already did this part here also. In the cat version of data, we apply the transformations and then we showed the images, right? uh, so same thing is being done there as well. Now we'll be able to see which kind of flower it is. After that we need to predict it, right? So you will be predicting it like this. It won't be hard, but this part you need to come up with yourself. Look at what is the top 5 classes mean. Okay, it's a very important parameter in accuracy. And so basically, the top k largest values you need to know with the highest probabilities they are getting. So it won't be too hard. You will just need to predict it using this way, right? And after that you can display the image along with top 5 classes. So you display a particular image and you see of the for each image there will be some probability associated with every class. So here if there are 100 classes, there will be 100 probability associated with each class. You will take out the top 5 of them and then you will show how much probability is in those top 5 classes. You see, this is stemless gentian, and it will be having highest probability in this part, but there are all 4 other classes which is it is having good probabilities, and all the other classes it will be having negligible probability, right? So now you just need to do this part. You need to show this image. And okay, even if the test, it's always good to check that these are not obvious. Okay, so you need to see, even if you are getting a very high accuracy, whether you take out a random sample and then you print its image and the top 5 probabilities which you can get here, right? After this you just need to show the image and then you see what kind of probability it is getting. So up till this part, I guess nothing was that difficult. All of these have been done earlier: loading the data, labeling the mapping, building your own network, testing your own network, saving the checkpoints, loading the checkpoints, then pre-processing, then I am show. Pre-processing I did right now. Maybe you can use this code. This is not that this is quite standard. Then I did the predict part. Okay, so I did not do the predict part, but you have to do the predict part, and it is shown that how you need to do it. You need to print the probabilities, and you will get the top 5 probabilities, right? Okay, what is now after you get the top 5 probabilities, you just need to make a graph where you will print the picture and the top 5 probabilities. You can do this on random images. Okay, so maybe so now you see the project is not that hard. Just complete the sixth, seventh, and eighth exercise. Take the help of webinars if you need to. There I have done all these 3 exercises in quite detail. Then jump onto this project and take those project samples, take those segments of the code from there, the exercises, and then try to run it on your own, right? uh, Maybe in second part there is this command line application. I don't have much time to discuss it right now, but it basically it you need to make it in this way that the evaluator just runs your code with some command line argument, and he gets the output in the specified format, right? You need to first understand how the command line things are done. So there is this terminal here. Okay. So in the next webinar, maybe we'll be dealing with this in quite detail. Okay. Okay. So it is taking some time. Right. Okay. So how do you need to run it? You need to go to this new terminal. You need to go to the directory image. You need to press the tab. Then you are in this directory. Now you can run train.py. Okay. So here it is, I have done this thing like I'm passing the one argument like, so let me pass python train.py, a project 2. So you see, it is printing the project to itself. So all the sys argument, these two arguments are being printed, right? This is my sys0 and this is my arg v0 and arg v1. So similarly, you have to do this in this project the way it is defined here. Okay. Yeah. So that's all for today. Maybe I'll be covering the next part about the. So in the next webinar, I'll be covering about this command line argument in detail. So till then, you just try to complete the first part. It won't be too hard, but it will take some time because you need to play around with some hyperparameters, run-ins for some accuracy values. It may be possible that some network is not being good. You need to load different models. Maybe VGG won't work, then you will need to run ResNet. But VGG works quite well. I'm just giving an example that you may need to change the networks, and then you may need to hyper tune your hyperparameters in the classifier. So this will take some time. Project is not hard, but it is quite lengthy. So in training also it takes quite some time. You please run your all the codes in GPU mode. Okay. Okay. Then I'll be sharing this webinar link on the channel itself, and then uh, we can talk about your doubts using our one-to-one calls. I see some of you already have submitted the projects, and others are also trying quite hard, so they will be able to do it on time also. Okay, so till next time, have a good day.